Hi, let's get started, and then the slow ones are going to miss out the best slides. At the heart of this talk is the concept of scalability, as defined as the ability, a system's ability to deal with growing demand. Scalability in itself, again, in the context of this talk, is very interesting, but we're not going to be thinking about scalability by itself. We want to be achieving scalability in a reliable manner, which means that we want the systems to be able to deal with growing demand, but also we want the customer experience to remain as good as it can be. And also in terms of efficiency, efficient systems tend to have their costs grow sublinearly over demand. So the more and more demand that we get on our systems, the cheaper we want the unit of cost to become. A little bit about me first. I started programming in the 80s by copying code from books into an Amstrad 6128. Anyone know what that is? Have you used one? Yeah? So that computer had 128 kilobytes of memory available. It's really interesting and fascinating if we were to contrast that with some of the talks today, like the one about running LLMs in Kubernetes, and we talk about the memory that running LLMs needs these days. 10 years or a little bit more before I was doing that, the Voyager 1 spaceship was launched, and that was running on 70 kilobytes of memory. Again, extremely fascinating, considering that its mission was to explore the outer solar system and beyond. And in fact, it has succeeded, and it keeps doing that on 70 kilobytes of memory. That's always been a fascination of mine, which drives my kind of passion for optimization in general. I started working professionally as an engineer in the early 2000s, and I like to mention one milestone in my career, which was in 2006 when I joined a company called ThoughtWorks, which was pivotal in the way that I approach building systems, but also because I met a lot of like-minded people there with whom I'm friends with, and some of them on and off colleagues. One of them, I was going to point him out because we came here together, but I think he's out dealing with a finger accident his daughter had. His name is Stuart, and I'll say hi to him when he comes in. The tool that I'm going to be working about is important to understand the context under which it was built, and that was for the company that I've been working for the last 6 years now, called Love Holidays. Love Holidays is an online travel agent in the UK, currently operating in the UK, Ireland, Germany, Austria, and the Netherlands. Love Holidays was established in 2012 and has been on a remarkable success trajectory since. The primary product of Love Holidays is a holiday package. That means that it's at its purest form a flight and a hotel package together. And there are some other things that we add to it that we call ancillaries, such as transfer from the hotel to the airport, parking, etc. You'll see why this is interesting. It's interesting because scaling for holidays is not easy. There's another person that I met at ThoughtWorks, Mike Jones, who is Love Holidays CTO. About 6 years ago, when he was getting ready to join Love Holidays, met up with me and asked me if I wanted to join him and scale Love Holidays up to, its next evolution in its journey. At the time, I thought, an e-commerce website is going to be a database, some JavaScript, some HTML, some servers in the middle. How exciting can that be? Mind you, at the time, I was on my 9th year working for a trading firm out of Chicago doing high-frequency algorithmic trading. So from a solving interesting problems perspective, I was at home. However, I was wrong about my assessment. 6 years on, the interesting problems that we can solve with technology only become more interesting and more satisfying when we solve them. Let me try and explain the scale of Love Holidays. Think about all the flights that flew in to Barcelona today. I asked, I should know this because I work in travel, but I asked ChatGPT, and how many? 475 arrivals into Barcelona today. Then I asked how many hotel rooms there are in Barcelona. Let me find it. Anyway, I remember it. It's 43,000. So, and that just starts to explain what happens there, because for each flight there are different fares. You must know that you can pick seats on a flight, and business class is more expensive than coach, and within coach a lot of the time you have priority boarding. Rooms themselves have different characteristics, such as the board basis, whether the room comes with breakfast or not, different occupancies. Multiply the one with the other, you're already starting to get a big number. Then multiply that by 365 days, or double that, because we offer at least 3 years worth of holidays on our website. Then do that for the entire world, and you get what this chart is showing, which is the number of holiday packages that we process annually at Love Holidays. The y-axis looks like what happens when you fat finger a multiplication on a calculator. Can anyone tell how many packages we process in 2024 by reading that number? Don't look at me, look at the number. Anyway, I'll help you. It's 1.7 quadrillion packages. And in 2025, we are on course to process 2.2 quadrillion packages. That's a very, very big number. I wanted to compare this with something, to bring it into perspective, and I kind of like riffed on the Voyager 1 analogy and asked ChatGPT how long would it take Voyager 1 to travel 1.7 quadrillion meters outside of the solar system. And I forgot, I don't want to open my phone again, but it's in the millions of years. What's sad about that is when I asked it how far would it get, it would actually still be inside of our galaxy, the Milky Way, which goes to show that if it's scale that you're really after, I mean, you know, you can come to Love Holidays, but you're better off becoming an astronomer. Our website is very fast, and one of the features on it is what we call any search. Whereas most travel websites will ask you the dates that you're traveling for or the destination where you're going to. Ours doesn't. You can start with nothing. What specifying a destination or dates does is reduce the search space. We don't have that. And then if you take that and think about how we also are able to sort that space by different sorting algorithms, such as price, you see how it's an interesting optimization problem, not something that you can achieve very easily. Now, what this chart shows is our search services latency. And the blue line says that half of our requests complete within 35 milliseconds, and only 1% of our requests take more than 200 milliseconds. The load on our website is variable. It's not constant during the day. It will become clear why I'm talking about this in a few slides, by the way. So you can see here, this is the load on one of our services during a normal day. Because, as I mentioned, we only trade in Europe these days. Things get pretty busy around 8 in the evening, essentially, and in the early AM, most of us are sleeping and not booking holidays in Europe. Load also changes month on month in the UK, and I recently found out that in Germany as well, and in Ireland, a lot of people tend to book holidays in January I'm originally from Greece. That wasn't a thing in Greece. So I was pretty surprised when I first found out that after Christmas Day, everybody goes and books holidays. I guess, the dark winters make them depressed, and they need to spend some money on our website to make it all go away. We said we want to be efficient, right? Being efficient means using less resources. We employ auto-scaling quite heavily on our website, and what this chart shows is, you've already seen the blue line, which is the throughput. The red line shows the number of pods that are running at the time, and that's the effect of auto-scaling. It means that we're only using infrastructure as we need it, rather than paying for it all the time just to cover the worst case scenario. This culminates into this, which is a metric, and especially its results, something that we're very proud of. This tells us how much it costs us in infrastructure to serve 1,000 sessions on our website. And you can see that the more successful we become, we also become the more efficient. The more users that we get on our website, because of all the optimizations that we've made, it's becoming cheaper and cheaper for us to run it, proportionally always. And remember, I mentioned 3 things, right? We want to scale. We want to scale efficiently, and we achieve that by not overutilizing resources. But we also want to scale reliably. We want to be there for customers to book holidays and to assure business continuity at all times. This is our uptime, which is typically sitting at 99.99%. But the way that we measure uptime is the number of 5xx HTTP responses over the sum of all the requests. Now, why is this talk about load testing? I haven't talked about load testing at all yet. It's because we want to know that our system can scale before our customers and also our budget find out that they can't. I'm sure a few people in the room, if not everyone, has been in a situation where they got unexpected traffic on one of the applications you're responsible for, and then the systems couldn't cope, and you had to do something about it. Load testing is a way that allows us to do this. Like all testing, testing is about simulating user input. Think about unit testing. When you write a unit test, you're trying to guess and simulate what an actual user is going to do with your system to try to make sure that it will work. There are a lot of great load testing tools out there. K6 by Grafana. The little manga guy in the middle is Vegeta, which is a Golang load generator that I use a lot all the time, and in fact it inspired a lot of what this talk is about. There's good old Apache HTTP perf that I've been using for the last, 20-something years. AB is another one. So there's a lot of great tools out there that help you do this. We want user-realistic load tests. Most of the tools that I mentioned, they tend to generate load at a set rate. You give it a request, and you say, run it 100 times a second. Users don't behave like that. User behavior is a lot less static. There is a high degree of diversity and nuance in the way users do things. That's why users manage to break your applications better than anyone else. This is a very high-level, very, very high-level version of our runtime architecture. The guy smiling on the left is a user. The first thing that they hit when they make a request to our website is our CDN. Our CDN happens to be Fastly. Fastly then hits Nginx, that acts as a reverse proxy, sending requests to our front-end services, which in turn talk to our back-end services. The interesting bit about this picture is the box at the bottom, which is Grafana Loki. If you don't know Loki is Grafana's open source log aggregation service. Loki enables us to store terabytes of logs at remarkably low cost. Is anyone running their own Loki anywhere? Oh, you gotta try it. Yeah, I mean, you can tell it's peanuts, right? Not nodding. Haven't measured it. Measure it. So yeah, if you want to check our tech blog, which I will share later on. We explain how we do it and why it's so cost effective. But the thing to remember here is that because we record many logs, what goes from Nginx into Loki is access logs. Access logs are a record of what users do with your system. In order to create user-realistic traffic, we took those access logs and we run them through a system that we call Owlbot, that is a cool name and a fancy little icon that we had someone design before AI could design things for you. And that runs within a Kubernetes cron job using a open source load generator that we've built called Ripley that we're going to talk about in the next few slides to replay those access logs against our infrastructure. Take a picture of this. I think it's worth making a note of this tool and checking it out. I'll give you a second. While you're doing it, I'll explain that it's called Ripley because it replaces HTTP traffic. Get it? But also because of Ripley from Alien. If you don't know Ripley from Alien, go. You must. So Ripley does one thing. It replays HTTP traffic at multiples of the original rate, but it has one important trick up its sleeve, which is it understands the timestamps of requests and uses them to replay the traffic as it happened. And that's what makes it user realistic. If there were 5 seconds between two requests, what Ripley is going to do is it's going to replay the first request, wait for 5 seconds, and then play the second one. Now, if you take like a prolonged period of activity on your website, like 1 hour, you can essentially recreate exactly what your users did for that 1 hour. Now, the other thing that Ripley can do is it can replay those requests at multiples of the original rate, which helps you simulate what would happen if, say, 10 times the users came to your website and did that thing. If you look at this command, this is what it's telling it. It's the right part of the pipe, and the pace parameter, the pace argument tells it, replay these requests at 1x the rate for 10 seconds, then at 5x the rate for 10 seconds, and 10x the rate for 1 hour, and see what your systems do. This is what it looks like from a load perspective when Owlbot runs. Oh, by the way, it's called Owlbot because it hunts at night. Remember that I told you that we operate in Europe, so our website tends to be quiet overnight. That enables us or allows us to be a bit bold and run load tests against production every night. It is somewhat risky because we can just destroy the website and come in the morning and it's not running. But the discipline you get from doing this every day means that that's never happened in the last, I don't know, 4 years or 5 years that we've been running this in production. What happens is some systems will melt from time to time when we go to new extremes. But generally, our infrastructure is set up in a way that those can self-heal, and we will come in the morning to a lot of errors. And that means that we have our work cut out for us, ensuring that those systems can scale for that level of traffic. But what's cool about that is we do that without any customer impact. We predict what can happen, and then we can preemptively fix things. So you can see the hump That's a lot more requests running between 3 a.m. and 5 a.m. every morning. Our traffic isn't normally bursty. That means that we don't go from 200 requests a second to 2,000 requests a second in 1 second. That is unless we're getting DDoSed or scraped or some sort of malicious activity. We have different systems in place to protect us from that, and they usually tend to be successful. The few times that they managed to break through, it was interesting. So far, it was never catastrophic. But what we saw was a degraded customer experience for a few minutes until our systems managed to auto-scale to be able to absorb the load. But at the same time, we got in touch with our bot protection provider and upgraded it so that those malicious requests didn't make it through. So our traffic ramps up slowly. That's what happened. It's like people start coming back from work, or people turn on the computers after dinner and start searching for holidays. Like, think about it. We're all at home. We're not going to turn on the computer and press the button at the same time. And because a lot of this has to do with us wanting to have user-realistic load testing, we want to simulate that as well. So at first, classic engineers, we tried to come up with clever algorithms about how enabling Ripley to simulate this, but at some point we just realized we have the way to configure pace within Ripley. Why don't we just do that? And these step changes that you can see here, they basically mean a very, very long line like this that says run the load at 0.5, the original rate for 5 minutes, then at 1x, then at 2x, then until you get up to, these days, we go up to 8x. We released Ripley, I want to say, 4 years ago, before peaks, just in time for what we call peaks, which is January. And that helped us keep our website up since. But one thing that we noticed soon after that was that Ripley wasn't producing the levels of load we were actually expecting from it, which is like a double irony, because the tool that's supposed to help you scale doesn't itself scale. So let's talk a little bit about how we tackled fixing that. The first thing that we did was create a repeatable test harness so that we can keep running it on our laptop using the same data. If you have the same inputs, you should be able to expect the same outputs. I know this is the graveyard shift, so probably our brains are not at full capacity. I'll try to explain this. Help me by nodding if you understand it. If you take 10 minutes worth of traffic and replay them at 1x the rate, it should take 10 minutes for that run to finish. Does that make sense? Yes. So if you replay that at twice the rate, it should finish in 5 minutes. Yeah? So you get the idea, right? If we want to test it at extreme levels, our harness went up to 160 times the original rate, where you would expect to replay 10 minutes worth of traffic in 375 seconds. This is what happened. The red line is the expected performance. This chart shows, in my glasses, I can't see. So the red line tells us how long we expect the run to take. On the left, that is the pace. So at 1x, you can see it's very high because it should take 600 seconds, meaning 10 minutes. Then all the way up to 160, it goes down to below 5 seconds, which was at 3.75 seconds. Give me another nod to know that you're following, because I think this is a bit tricky. Cool, thank you. And then the blue line is the actual performance. What's really interesting about this is that Ripley, this tool, didn't do well in the beginning and then started failing at the end just because we were overloading it. It was drifting very, very early on, so something was going on there. This is Golang. Let me give you 1 second to just read like the 2 lines of code. I think it should be easy enough to understand. So what Ripley does, of course, this is almost pseudocode. It will take an iterator of requests and go over the requests one by one. And like I said, between the current request and the previous one, it will take the difference between the 2 timestamps and sleep for that amount. That's all there is to the algorithm, nothing magical there. However, there is something very interesting that it's, I think, easy to not notice, which is that comment in there, that other code. After digging into it and banging our heads against the wall for a while, we realized that that other code, whatever it is, itself takes time to execute. And if you think about replaying thousands of requests a second, that latency adds up. Like if every request has a penalty of 2 milliseconds or 1 millisecond or a few microseconds, 1,000 a second is a lot more than that. And when you do that for 10 minutes worth of requests, it will add up. We introduced the concept of a wall clock to adjust replay space so that it takes account of this drift. There is a PR in the GitHub repo that shows how we do that. I'm not going to get into it now, but if you're interested, let's have a chat afterwards and I'll show you. This is the result after our optimization. And you can tell for paces up to 80 times, we got almost bang on. We didn't quite manage to finish 160x the pace at 3.75 seconds. There's something else, some other constraint there that we actually didn't go as far as figuring out, because 80 times the normal load on our website is more than enough for our use case right now. But yeah, like if I started talking about what might be causing that, I will start speculating, and I don't think that's useful for a conference talk. Some tips when you do this, because I hope some will go back to our day jobs and apply this to make sure that our systems stay up. Ripley specifically can replay incidents. Have you ever had to deal with an incident, made adjustments, but had to wait until the conditions that caused it to happen again in order to prove that the fix worked? Like, I've done this a lot in my career. Like, something would break, we would work all night, everything would seem fine. 48 hours later, it will break again. Oh, what happened now? And if you have the access logs and you can replay the access logs, you can replay exactly what the users were doing at the time, so you can make sure that your fixes actually had effect. That is, of course, barring things like hardware failures, which are a different thing. Like, if you had a hardware failure, then you fix the hardware and create some redundancy for the next time, and then hopefully you won't have that problem again. We actually didn't make this mistake. I'm thankful that we thought about it before it actually happened and prevented it. But if you are replaying traffic at multiples of the original rate and you're hitting third-party APIs that you're either paying for or are your partners, we have a lot of suppliers. They're not ready for 10 times the traffic every night. So do them a favor and spare them from it, or spare your wallets, because let's say you have like a very pricey Vertex AI integration or something like that, and somebody has budgeted for it to be used as much as your customers are using it. This will expand your bill. Be careful about replaying writes. again, this is something that, especially, against production, right? This is something that we were intentional with from the moment that we started. Like, in the context of Love Holidays, when customers book, they make a booking, we write something into a database. If we were to replay all of that and it actually made it into a production database, we would wake up one morning and we say, oh, wow, we just made 10 times more bookings. That's amazing. How did we do that? Let's just, give ourselves huge bonuses because we've done something right. But of course, it would have been not true, and it would have been something to solve, and so careful about that. We were very paranoid when we started, and we only tested it on the read-only parts of our website, and then as it evolved, when we wanted to test the performance of writing as well, we created specific pessimistic strategies around, or paranoid strategies around doing that. PII, I hope you're careful about personal information. Nobody should have access to it really, unless it's really needed. In fact, I went to a talk about privacy this morning. The speaker was arguing that you shouldn't even be recording that private data. I can't really argue against that because there are ways to get the information you need without private data most of the time. But if you work in anything that has to do with customers, you're dealing with private data. Ideally, your access logs should be stripping it out. But no matter what you do, when you're replaying these things, don't make them visible to people or systems that this private data shouldn't be visible to. Technology as a means to an end is one of our 5 tech principles at Love Holidays. We love being engineers. Being an engineer is about using knowledge and tools to build things that are useful to someone, hopefully to many people. And we don't just build systems for the sake of it. We build systems to send happy customers on their favorite holiday, but also run a successful business so that we can pay our salaries and invest in building even cooler technology. So what's the outcome? We always ask, what is the outcome of our work? So what's the outcome of all of this stuff that I've been banging on about, load testing? And this is last year, I think, 2024. This the x-axis is the dates, and they start from around before Christmas in December into January and February. These are the peaks I was talking about. The blue line is the throughput on one of our services. You can see that it more than doubles between late December and January. Whereas the red and the yellow lines are latency. So you can see that because of all this hard work, a lot of customers came onto our website. In fact, it was a record year. I think we broke a record in January, hitting 12,500 requests a second, all the while the latency remained exactly where it needed to be. So the customer experience also remained exactly what it needed to be, and that feels like a great achievement to me. It was very satisfying watching that happen. This is the end of the talk. I can never get it right, which is the left or the right, but the thing that says tech.loveholidays.com is our blog. I do encourage you to visit it. We talk a lot about how we deal with technology and all the cool things that we build. And if you want to know how we build systems that can sort 1.7 quadrillion, on a daily basis is a few billion package combinations sorted by price in 35 milliseconds, then the only way to find out is by working with us. The mic's coming.
Hello. Okay. Yeah, I'm sorry. I don't want to waste anyone's time if they already know the answer to this, but I'm a QA engineer and I'm interested in load testing. And it caught my attention when you spoke about doing load testing with writing in production, and you said you had a paranoid approach to do that. And I was hoping if you could get into a little bit more detail in that regard.
Yeah. So we are replaying requests. The simpler way to think about a request is it's an HTTP request. It's either GET or a POST, and it's going to an endpoint. It's very, very likely that your application has different endpoints to write something versus to read something. So when we curate our logs for the purpose of load testing, initially what we did is we stripped down all of the endpoints that would write. In fact, the paranoid aspect is that we didn't create a whitelist. Sorry, we didn't create a blacklist. We didn't say exclude these. We said only allow these. So that way, unless you go and change like a get to a put and make something that says search actually write to your database, it's harder to get it wrong. So that was. Did you get it? Let's take it again slowly. So HTTP requests, you know that. Do you know a get and a post? Okay. So if you had like a /search on your website, that would, in RESTful terms, would be a get. But the important aspect here is search will do a search. You want to allow that to be replayed, whereas the one that is /by, that will write. So you say don't replay the one that says /by.
But then aren't you skipping, aren't you doing a reduced version of what actually happened?
Yeah, absolutely. So you don't load test the /by.
Is there a way to do that in production?
Yeah, there is, but it's trickier. You have to abstract away the database itself or create a fake database to write to if it's the database that you want to be load testing. So if you create like a mock database that can simulate the database's behavior, you can do that and mock right into that, and every other upstream system will be load tested, but then you'd still be safe.
This might be a stupid suggestion, but could you just have like a flag to the right, and then at the end of the load testing, like remove all that added data?
You could always have, so you're saying write 100,000 times to your database, but then you can remove that data because it's been marked as, I think given the conditions, you can do something like that. Yeah. Cool. Thank you for the question.
Hi.
Hi.
So I mainly had questions similar to what he just asked, so that's cool. But the other part I was wondering, well, in general about state, but about, for example, if some requests have a state which does not exist anymore, so you are trying to replay, for example, trying to see some promotion or to see some offer or something you have on your page, and this offer does not exist anymore, this request should not work anymore because the state's changed on the database, so you cannot really replay it. And also pages or accesses that don't make sense in a user journey. So if you're trying to go to a certain page that only is available if the user has certain access, so certain access level, or if it's only available after you click some other stuff on the page, how all of this was taken into account to do your load tests.
So are you asking how do we make sure that a page gets reached?
Yeah. How do you know that those requests you're trying to replay make sense or are able to?
Well, they make sense because users did it. They make as much sense as a user doing something on the website.
Yeah.
So from that perspective, I think the reverse to your question is, how do you make sense of your load testing if you don't base it on access logs?
Yeah.
Which is what this is trying to solve. Because I've seen it many times in the past using tools like, let's say, AB. You said, oh, we just built this new endpoint and we care about its performance. Let's send 1,000 requests a second to it, see what it does. That by itself is never what happens to a system. While 1,000 users are hitting one endpoint, there's another 1,000 hitting another endpoint, there's another 1,000 creating errors because they did something that you didn't anticipate. So it's the combination of all of those that this type of testing, that is not synthetic, this is just replaying real stuff.
Yeah.
This is what makes it realistic.
But about user levels or user access, does this take into account like cookies or things like that, or it doesn't affect yours?
It does use the cookie because it does send the cookie because the cookie is necessary to serve the requests. We don't do it on anything that is hidden behind user accounts.
Okay.
Yeah. And from load perspective, at least in our case, the majority of traffic is traffic that doesn't have to do with rights, and it's traffic that doesn't have to do with things that are behind an account. If you think about it, we make thousands of bookings every day, but we have millions of requests every day. That's like how successful you are as a business, is how many users you convert, and usually conversion levels tend to be a lot more reasonable than people shopping around.
Makes sense. Yeah. Thanks.
Thank you. So every day we use the logs from yesterday evening. That's something I learned when I was training machine learning or statistical models way in my past. You want to bias yourself to recency because that's most likely what's going to happen. However, when we want to push our systems, then we will find days that we're more busy. And there are cases where you want repeatability. If you want to fix something and you keep changing the inputs, it's not as easy as having a static input to your tests. And that was, I don't know if you remember when I was explaining when we optimized Ripley and I showed that weird graph about 10x, 160x. That's exactly what we did. When we want to do something specific, we pin the run to a specific data set until we can make it work, and then we go back to. Thank you.
Quick question about load testing during the night. Like every distributed application, the pods will scale while you're running the load test, and this will have a cost, right?
It does.
Even if they are spot instances, for example.
They are spot instances a lot of the time,
There will be a cost, in a moment that you don't expect to have this cost. So how do you justify this?
We worked it out, and our website going down for 2 hours during peak periods is a lot more expensive than us running this. Yeah.
Then you also have load testing also
while
coding for developers. Developers will be loading.
No, because this covers it for us.
Okay.
Yeah, I mean, locally, you might micro-optimize something, but once something goes into production, because we have like a variety of systems, of course, we have a lot of monitoring and alerting as well. So our monitoring systems will definitely notify us if the latency of a system becomes worse during the day. So we will match that with a certain release, roll it back and figure it out. But yeah, this gives us a lot of confidence to actually catch sneakier regressions. Not currently, no. Yeah. As many as you want. I can be here all day. I love talking about this stuff.
Hello. Well, let's suppose we don't have that window of time that being in Europe give us. I mean, if we have to serve queries from America and Asia and Europe, and we don't have that window of time, what are your thoughts about this? How would you manage this scenario to do this kind of testing?
A sensible person would set up a production realistic staging environment and do it on staging, or a specific environment that is independent to your productions. For that purpose, I would personally still do it against production. It's really cool to get to a level of confidence where you can run chaos engineering and actually be able to deal with it without your customers knowing. So, you know, be an engineer, make your systems reliable, make your system scalable, and then, you know, have the guts to do it in production. But don't take my advice on that. Don't. But that's what I would do. Does it make sense? Okay.